we still had to mark 6.6 and 6.7 from Friday. We didn't manage to mark that. So the first 5 questions from number 6, those answers and me explaining everything, that will be on that video from Friday. And then you also have to do number 7. So that's what we're going to mark now. 6.6, 6.7, and 7. Okay, so just to remind you, that was the picture for question 6. Right, and in 6.1 to 6.5, we obviously had calculated various things, but the things that we had proved was that this whole shape is a cyclic quad. All right, that was the very first question. So we worked with converse angles in same segment because that is x and that is x. We said that has to be a chord that's obtaining equal angles at the circumference. So this whole shape is a cyclic quad. That was 6.1. All right, then in 6.2, we proved that AC bisects this whole angle. So in other words, that is x and that is x. All right, that was what we did there. And then people in the class, I can't remember who it was now, but came up with a shorter method than what I did. So we wrote that shorter method down. In 6.3, we proved that DG is equal to FG. All right, so we did the, not inverse, the converse basically of equal chords, equal angles. All right, so remember that if you have equal chords, they will subtend equal angles at the circumference. So we saw that these 2 chords already subtend equal angles at the circumference, so they have to be equal. So that is why the reason is swapped around. It's then equal angles, equal chords. All right, that was 6.3. In 6.4, we proved that we had to find the value of C2, I think. So we said that D2 is 90 because it's subtended by that diameter. But then in the whole cyclic quad here, remember, if we prove that this is a cyclic quad, we can use that going forward. AB is actually also subtending D2, which is 90. So then because it's also subtending C2, C2 will have to be 90 because of angles in same segment. All right, then 6.5, the last one that we marked, they just asked us to prove that O2, which we calculated in various different ways. We discussed lots of different ways of doing it. We found that O2 was 2x. All right, so I just did angle at center for O2 to get that that one is 2x. And then if they're asking us to prove that O2 is equal to G1, we had to prove that G1 was also 2x. So what I did to get G1 is I looked at this cyclic quad there, right, which we can see because it has all 4 points on the circumference of a circle. And in that case, G1 is actually an exterior angle because it's one side of the cyclic quad that's been lengthened, and between the other side, that is an exterior angle. So it should be equal to the opposite interior angle, which was 2x. All right, so that is how we proved that O2 and G1 were both equal to 2x. All right, that's how far we got. 6.6, sorry, they asked us to prove that FBCG is a cyclic quad. So FBCG, so it's this outer one here, right? So I'm sure there were lots of different ways to do it, but what I said was C2 was 90, all right? We proved that here in 6.4, we got that C2 was 90. Maybe let me just do this, then it's a bit clearer what we're actually looking at. Oh, that's skew. Sorry about that. Okay, that's what we're trying to prove. Can you guys make that out? Kind of. All right, that's what we're trying to prove, that that's a cyclic quad. So I said that C2 is 90. We have that already. Okay, so if I can prove that F1 is also 90, then I will have that opposite angles are equal to 180, right? In which case it is a cyclic quad. So for that, I looked at this cyclic quad there. Right, if that one is 90, then F1, the exterior angle of the cyclic quad, will also be 90. Right, does that make sense? So I used exterior angle of the cyclic quad for this one to prove that F1 is 90. We already knew that C2 was 90, so if I then add those two together, they equal 180. So it is then a cyclic quad. All right, so that's how I wrote that out. C2 equals 90. You didn't actually have to state this again, all right, because we had written it down previously. Then F1 was 90 because it's an exterior angle of this cyclic quad. Again, guys, you don't have to name the cyclic quad in your reason, but it is nice to keep track of what you're doing if you do that. Okay, then you can add that. Don't really have to, but you can. That if you add them together, it's equal to 180 degrees. Therefore, it's a cyclic quad, converse of angles of cyclic quad. Remember, when we're proving that it's a cyclic quad, we have to put the word converse in the reason. Yes. Okay, is that fine for 6.6, guys? All right, 6.7 was an interesting question. What was the wording? Let me check here. They said, for what value of x will DC, let me just go up to the picture actually. For what value of x will DC be a tangent to the circle through F, B, C, and G? All right, so now we did already prove that this is a cyclic quad, right? So we know that there can be a circle drawn through those 4 points. But now they're saying, for what value of x will DC then actually be a tangent to that imaginary circle, the one that we can't see there? Now guys, what you have to then kind of use is, if DC is a tangent, then tan chord theorem will work. All right, does that make sense? If DC is a tangent, then remember, if the circle is going through these 4 points, that GC is going to be the chord that we're going to look at. All right, GC will be the chord and DC will be the tangent. So which angle is between the tangent and the chord? That one over there. All right. Now I had to calculate that one because I hadn't actually calculated C1 before. But earlier on in the question, we calculated that the whole angle C was 180 minus 2x. And that one there is 90. Okay, so I used that to calculate C1. So I said C1 is 180 minus 2x. We calculated that in 6.2, that whole angle there. All right, that this is 180 minus 2x minus that one, which is 90. So that's how I got C1. That was the first thing I had to actually do. Okay, C1 would then be the angle between the tangent and the chord. Now, if we're using tan chord theorem, C1, and that one is the chord, right? And remember, there's a circle going through these 4 points. Which angle is then subtended by this chord on the other side of the chord? B1, right? Because remember, there's now supposed to be a circle going through those. So B1 will be at the circumference of that circle. So guys, if DC is a tangent, then these two angles are supposed to be equal. Right? 90 minus 2x is supposed to be equal to x. Okay, that kind of makes sense. But then if you have an equation like that, then you can solve for x. So that's the first thing that I did. I found that C1 is equal to that whole angle C minus C2, which was 90. Okay, so this was a whole angle C minus C2, if you want to add that in. So that's how I got 90 minus 2x. Then I just wrote this part here. You don't have to write this down, but this is just the explanation of what I did after that. If B1 is equal to C1, B1 was the one at the circumference, and C1 is the one between the tangent and the chord. All right, so if those two angles are equal, then DC is a tangent. All right, and they're saying, if DC is a tangent, what is x going to be equal to? So then I made those two angles equal to each other, right? This was B1. And that was C1. And then you can solve for x from there. Okay, that was a very tricky question because you couldn't see the circle. You had to make them equal. You first have to find C1 as well. All right, so if you get a question like this, it will definitely be like the last question, one of the last questions in the test, right? One of those problem solving ones. All right, are we fine, guys? Remote over there. Okay, I will post, even though you guys are all at school, I'm still recording my lessons and I'm still going to do like a daily thing like I have been doing. I think it's nice to keep track of stuff that way. So I will post this. Yeah. Yes, I'm doing that now. Okay, thank you, thank you. There's number 7. Thank you. Let's be quiet, please, so that I can explain this. All right, number 7 was an 8-mark question. They just gave you the picture and they just said, prove that O2 minus A is 180. Okay, there was no, we call it scaffolding. They didn't break it up into separate questions. All right, it would have been easier if they said 7.1, find O2. 7.2, find A. And then 7.3, show that this. Okay, usually they put these kinds of questions where it's just a question and it's like 8 marks or whatever. This will normally be like the last question in the test. Okay, the problem solving question. So this one actually wasn't too bad, but there was some stuff that you had to prove here. So guys, if they're saying that you must prove that O2 minus A is equal to something, find O2 and find A. All right, they are leading you in what you actually need to do. So if this is X, do we agree that O1 is going to be 2X because of angle at center? And guys, even if you can't go further, you'll still get a mark, maybe 2 marks for that. All right, probably 1 mark, but yeah, that's better than nothing. Right, 1 out of 8 is better than 0 out of 8. So what I was saying to the group that was here on Friday, if you don't know where to start, just start calculating angles. All right, because sometimes you will get marks for those angles. So I think you all can see that if C is X, it's at the circumference, O1 is going to have to be 2X. All right, it's at the center. Now remember they've asked us for O2 minus A. So if we have O1, it's very easy to get O2 from there. We're going to use angles around a point or revolution. So O2 is just going to be 360 minus that angle, 360 minus 2x, revolution, all right, or angles around a point. There you have 1/2 of what you're needing to prove. Okay, now I'm sure there would have been other ways of finding A, but what I did was I said, okay, what if this shape is a cyclic quad, right? Just hold on, Jasper, let me just do my explanation. If this shape is a cyclic quad and that one is 2x, then that one is going to be 180 minus 2x, right? Because of opposite angles of a cyclic quad. So then I started looking at how could I possibly prove that this is a cyclic quad. Now, guys, do we see that this is a radius? And they told us that this is a tangent. And we know that a tangent is always perpendicular to a radius. So that one is 90. But don't we have the exact same thing happening here? Again, we have a radius and that is a tangent. So that one is also 90. Okay, so you can see I wrote them both in one line with that one reason, because it's the same reason for both of them. You can do that. And if that's 90 and that's 90, then opposite angles add up to 180. All right, so then it is a cyclic quad. Converse of angles of cyclic quad. So then if I know that this is a cyclic quad, then I know that these angles must also add up to 180, these two, if I add them together. So if that one is 2x, the opposite one is going to be 180 minus 2x. All right, so first you prove that it's a cyclic quad, then you use cyclic quad properties. Okay, so then you say opposite angles of cyclic quad, that's the reason there, because we now know that this is a cyclic quad, right? So we can use that. And then we have O2 and we have A. So then we just do that final step of showing that O2 minus A, right? If I do that calculation, does in fact give me 180 degrees. Okay, before we look at other options, any questions on this method that I did? Okay, you fine? Talia? Yeah, and then?
And then just use properties of fact, because then I said that I should do off the 2 and 9, so that A would be bisecting by diagonal type. So there would be use like the angles of the triangle.
Okay, so then if that, so that will then be x and x.
Yeah.
And then you use angle sum and triangle like that. Yeah, that's fine. Jasper?
Now is angle sum and quadrilateral.
Yes.
Can
Equals
you-
360.
Because
Mhm.
that's what I think.
Yes.
Just be 360. Not
Minus 180 minus 2. Yes, yeah, you could have done that as well. That actually would have been quicker. All right, so guys, if you have this and this and this, and you know that this is a quad, remember that the angles in a quad add up to 360. All right, so instead of doing this, you could have said, I don't have a lot of space there on the side. You could have said that angle A is then 360 minus 90, and 90 together is 180 minus 2x, which is then 180 minus 2x, but then your reason will have to be angle sum in quad. Okay, yes, thank you. Could have done that. Okay, any other suggestions? Right, all fine. Will you be able to do a question like this in tomorrow's test? Surely at least you can get to 2x. Right, so no one, I think, in this class would have gotten 0 for this question. You all at least could have gotten that first mark. Hey, and then by a bit of a stretch, maybe the next one also. All right? Because they said O2. All right, are we fine, guys? Getting A was a bit more complicated. 2, maybe 3. It says 8 in the textbook here. We would probably give it less marks. So yeah, I would probably say 1 mark there, then 1 mark there. I think you should expect a combination. All right, so they won't only ask like I mean, I can't remember. I looked at the test a long time ago. But yeah, you could expect something like this. Yeah. Yes, I will. Yeah, sorry, I wanted to do that. Yes, I will. Okay, sorry. So we were saying 2 marks for that, then probably 2 marks for getting to those angles, a mark for getting to A, and then a mark for showing the minusing. So what's that? 1, 2, 3, 4, 5, 6. Right. Okay, we are doing trig. Guys, please write a new chapter heading. Thank you. Let's stop talking. Thank you. Thank you. Let's focus. All right, copy that down, please. Thank you, grade 11. You're being rude. Ayaz and Talia, can you stop talking, please? Copy this down. Okay, guys, there at the top, sine, cos, and tan, you need to know what those letters stand for, O, H, and A. All right, O is for opposite, H is for, do you remember what continues, and A is for adjacent. All right, so guys, we only work with those ratios in right angle triangles. We are going to work with them now in the example, because we'll go over that again. You might remember that last year you did the reciprocals as well. So you did sec, cosec, and cot. We don't do them again. All right, going forward. So we only have to worry about sine, cos, and tan from now on. Okay, we're not going to do cosec, sec, and cot again. Okay, so those are the only 3. It's quite nice. There is a little, like a, I don't know, abbreviation, I suppose, to remember those. Did you learn those last year? SOHCAHTOA, yeah. So for sine, you can remember so, and then for cos, ka, and then for tan, toa. Right, that's just a way of remembering the OH, AH, and OA. Okay. But we're not going to ask you in the test what is the abbreviation. All right, that's just like a memory tool. Okay, then the class diagram, you might have seen that last year, you might not. So we see that we have a Cartesian plane over here. All right, and the Cartesian plane is split up into 4 quadrants. So the first one, this is the basic one, all right, where x is positive and y is positive. This is the first quadrant. The A here stands for all. So this is saying that all the trig ratios will be positive in this quadrant. All right, we're going to work with trig ratios in different quadrants now in the example so that you can see. The second quadrant is the one next to it. Now, guys, do we notice that in the second quadrant, we're going to have negative x values, but still positive y values? All right, so if you were to plot a point here in this quadrant, I mean, you'll have a negative x value and a positive y value. S is over here, if we know our cast diagram thing, meaning that only sine is positive in this quadrant. All right, sine is going to be opposite over hypotenuse. All right, that will give us a positive answer. Cos and tan will be negative. We're getting values for cos and tan in this quadrant, they will be negative. All right, quadrant 3, here we have negative x values and negative y values. Do we see that? All right, negative x values and negative y values. Over here, only tan is positive. Right, sine and cos will be negative. And then the fourth quadrant, we have positive x values but negative y values. Okay, in the fourth quadrant, only cos is positive. The other two will be negative. All right, so if you remember your cast diagram, now unfortunately it starts in the fourth quadrant and then it goes around like that. All right, but that is a nice way of remembering which trig ratios are positive in which quadrants. We're going to use it now in the examples. Okay, then you did these 2 special triangles last year. You have to know these off by heart. Every time we're working with 30, 60, or 45, you're going to have to draw the triangle next to your answer. Okay, you'll get marks for drawing them. So please, you do have to memorize these and draw them every time you use them. It's very important.
Do we need them as the fractions?
You can read them off from these triangles. Yeah.
Do we need the
Yeah. No, so for those, I think of the trig graphs rather, but we'll do those when we actually get to them. Yeah. But you do have to be able to do them without a calculator. Yeah. Okay, are we done? Can I move on? Not yet, right? Now, guys, if you don't want to memorize these triangles, you know, all 3 sides of both of them, I don't think it's that much to memorize, but you can just memorize 2 of the 3 sides and then find the third one using Pythag if you want to, all right? So if you remember, for example, for the 30-60, if you remember that the side opposite the 30-degree angle is 1 and the hypotenuse is 2, then you can find the third one using Pythag very easily. Same thing here. If you remember that if you have 45 and 45, you're going to have 1 and 1. right? Because obviously if it's two 45-degree angles here, it is an isosceles triangle, right? So if that is 1 and that is 1, then you can find the hypotenuse using Pythag. Okay, or you can just memorize them. It's fine, either way. All right, we are going to just do some examples. The heading is a bit clumsy. I'm not sure if that's the best heading, but yeah, in the text they just kind of say examples, there's no heading. All right, so you'll see now when we're doing it what I mean by that heading. You're working from one ratio to another. You did these types of questions last year where you have to draw a triangle in a specific quadrant and then use the values in the triangle to find other things. Okay, so just copy that down and then we're going to do that example together. We're going to do 2 full examples. Okay, now guys, I wrote here in blue on the side without the use of a calculator because sometimes in the textbook specifically, they don't say that you're not allowed to use a calculator, but these questions, when they come up in tests or exams, you will always have to do them without. Okay, so that's how we're going to practice it. Even if they don't say in the textbook, we have to be able to do these ones without the use of a calculator. So here the question is saying if cos theta is 8/17. Now guys, just before we even move on from that, do we remember what cos is? How do we find cos in a triangle? It's always adjacent over hypotenuse. All right, so they've given us in that first bit, they've already given us 2 pieces of information. All right, we can draw a right angle triangle just using that, making the adjacent side to theta will be 8 and the hypotenuse will be 17. Now guys, in a right angle triangle, how can we find the third side always? Using Pythag, okay? So if we do that, we already have a triangle with 3 sides. Okay, but now they're giving us more information. They're saying, and sine of that same angle must be negative. Then we must find the value of the following without using a calculator. Now, guys, sometimes instead of using the words without using a calculator, they say, so I'm just going to write here, or, not really. Sometimes they say using a sketch. Okay, so we are going to have to use it, even if they don't say even if they don't say using a sketch, we are going to have to, but sometimes they kind of swap between those 2 instructions.
We can use Pythag in general, but because it's not common number.
Oh yes, yeah. So you can use the calculator for that. They just mean, because I remember my first year at Westerford, the grade 11s, what they did was they said, okay, I have cos theta equals to 8/17. I'm going to do shift cos and then find what theta is and then just type it into my calculator. I'm just going to type tan of that angle and there I have my answer. Okay, so that's what they mean when they say without using a calculator. We're not going to solve for theta and use it, All right, we're actually going to draw a triangle using the information that they gave us and then find tan theta.
The more, if I remember correctly, from like 1 until 12, that's when it's like increasing that you can actually get that number by like mental. You can get the new fraction.
Yeah, no, you can use the calculator for the pi factor.
But once it gets past that, then
Yeah, so like I said, yeah, we don't worry about the pi factor for the calculator. Yeah, so we'll give you also numbers that you can kind of do. I'll show you now. Okay, so what we need to do here, guys, we can't just draw a triangle and say, okay, it's 8, 17, and we're going to find the third side, because our triangle has to satisfy both of these. All right, cos has to be equal to a positive value. Do we notice? 8 over 17 is positive. All right, I'm just going to write that there. This is a positive number. And sine must be negative. Now we need to use our knowledge of the cast diagram to find a quadrant where both of those conditions are true. Right, so we're looking for the quadrant because we're going to have 2 for each of them. All right, where is cos positive? What did we look at now with the cast diagram? Where is cos positive? In 1 and 4. Okay, let's write that down. Cos is positive in quadrants 1 and 4. So I'm looking at cos theta is equal to a positive number. All right, it doesn't really matter at this stage what those numbers or what that number is, but cos is positive in 1 and 4. And where is sine negative? Sine is positive in those ones, so sine is negative in 3 and 4. All right, because they're saying sine theta must be less than 0, must be negative. So this happens, or this is true in quadrants 3 and 4. Now guys, which quadrant satisfies both of those conditions at the same time? Quadrant 4. All right, quadrant 4 is the only quadrant where cos is positive and sine is negative. All right, so we are going to draw our triangle in the 4th quadrant. Okay, let's draw the 4th quadrant there, then we can fill everything in. So normally when I draw these quadrants, you'll see that I just kind of make like a small extension of the axes just to show. So like that, right? This is the 4th quadrant here at the bottom, but I'm just showing that there are still other quadrants also, but we're not going to use them. Okay, now I'm going to draw a triangle. I'll explain to you now why my triangle looks the way that it looks. Don't worry about scale. You're just going to draw a right angle triangle that is in the 4th quadrant like that. Please just indicate that it is right angled. Remember, we can only use sine, cos, and tan in right angled triangles. Okay, now guys, theta, right, for an angle to be in the 4th quadrant, it's going to have to be between 270 and 360 degrees. Does that make sense? An angle here will be like a 30-degree angle, for example, an acute angle, because we always start from the x-axis and then we go, what is this, anti-clockwise, right, when we're measuring angles. So a 30-degree angle, for example, any acute angle will be in the 1st quadrant. A 2nd quadrant angle will be between, we have 90 over there and 180 here. All right, so a 2nd quadrant angle will be between 90 and 180. The 3rd quadrant angle will be between 180 and 270. All right, so like 200 degrees, for example, because you're going from 0 to 200. All right, that will get you an angle there. An angle in the 4th quadrant is going to be between 270 and 360. Did we put that on our cast diagram? Yes. All right, so this is what I'm talking about. Okay, so an angle here is between 0 and 90. There is between 90 and 180. There is between 180 and 270, and here between 270 and 360. Okay, so guys, when we are showing our theta, we have to actually start at the x-axis, go all the way around to that line, and do an arrow like that. That angle is actually theta. Right, our angle actually has to be an angle between 270 and 360, so 300 degrees, for example. All right, so we have to indicate that on the picture. But we are actually going to use this small angle here as the reference angle. Now, you might have heard that last year. All right, we're going to do a lot of work with reference angles, reduction formula. So I will still explain to you why we can use this angle instead of the whole angle. Right. So just, I know it's not nice to do something that you might not understand yet, but that's still coming up later in the week. Okay, I'm going to explain to you why you'll get the same answer if you use the reference angle versus the whole angle. Okay, so we're just putting a pin in it, right? We're going to come back to that. So we're going to use this angle as if it's theta. I know it's not, but it's the reference angle. We're going to use it as if it is. Okay, so for that angle here, they told us that cos is 8/17. So the adjacent side to this angle has to be 8. Do we agree that it's this one? Right, so that length there is going to be 8. The value that we're going to use there is 8. And the hypotenuse is 17. Right, adjacent and hypotenuse. Now we need to find this side. Now for this, we're going to use Pythagoras. Now guys, do we agree that this is going to be a y length? Because if I read that length off, I would read it off from 0 here to whatever this value is on the y-axis. Okay, so I'm just going to call this y. You can call it whatever you want, all right? I'm just going to use y there because it is a y length, a y value essentially. So we're going to say that y squared is equal to, now guys, is y the hypotenuse in this case? No, so when we're finding a side that's not the hypotenuse, we always have to say the hypotenuse squared minus the other one that we have. So we're going to say 17 squared minus 8 squared, and we write Pythagoras. Okay, now here you can use your calculator. That's what Jasper was asking earlier. All right, we don't really care if you use your calculator there or not. It's fine. 17 squared, I don't think I even know what that is off by heart. What? Oh, the answer is 15. Yes, but I mean 17 squared. I don't know what that is. All right, so 17 squared minus 64, doesn't matter. You get an answer of 225. Okay, it's fine if you use your calculator for that, but how would we know anyway? All right, you might know what those values are. Okay, so now we're going to do the square root of 225, which is plus or minus 15. I know we don't usually do a plus or minus when we use Pythag, but in this case, we actually have to. Remember, guys, when you're taking a square over, you do actually do a plus minus square root. Okay, usually with Pythagoras, we just have a right angle triangle. We're finding the length, so we just do the positive one. But now when we're working in the Cartesian plane, y is actually not only the length of the side, but y is actually the y value of this point. Okay, just plot the point there. That actually is the point 8 and negative 15. Right, if we're going from 0 and we have a length of 8 on that side, that is a length on the x-axis. So that will actually give us the x value of this point over here. Right, does that make sense? If that length is 8, then this x value has to be 8. But now if this length is 15, that coordinate can't be positive 15, right? Because it's in the fourth quadrant. And we have negative y values here in the fourth quadrant. If that point was up there, then yes, positive 15. All right, but because this point is in the fourth quadrant, our y value has to be negative. Okay, so y is actually going to be negative 15, even though it's a length, right? The length of that side is 15, but the actual coordinate, because we're working in the fourth quadrant, is negative 15. I'll be with you now. Let me just write this here. You don't have to write this when you're actually doing the question, but because it's the first example, let's write that down. But quadrant 4, so y is equal to negative 15. Okay, when you're doing this in a text or exam or even in the exercise, you can just see, okay, I'm using Pythag. This must be 225. The square root of 225 is 15. But then you can just look and you could see, okay, it must be negative. So you can just write y equals negative 15 straight away. Okay, you don't have to write this whole thing. I'm just writing it so that you can look back at it. Yes, Jasper.
Amount of mistakes cannot negative at any quadrant, but you can't have a negative.
Tan is opposite over adjacent.
Oh yeah, so sorry. So the hypotenuse can never be negative.
Yes, but the hypotenuse doesn't come into play at all with tan. Because tan is opposite over adjacent. So you can have a negative one, yeah. Okay, guys, are we fine with that negative 15 thing? It is a bit weird, all right, but you need to look at the quadrant that it's in. Because remember, our class diagram says that certain trig ratios in this fourth quadrant must be negative. Sine must be negative, for example. Now, if sine is opposite over hypotenuse, if this is positive 15 over positive 17, is that going to give me a negative value for sine? No, all right, because if you have positive 15 over positive 17, that will give you positive 15 over 17. And sine in the fourth quadrant is negative. And it's actually because of that. Because the opposite side, because it's the y length, and it's on the negative side of the y-axis, will always be negative here. So opposite will be negative over hypotenuse, which is always positive. All right, that is actually why sine is negative in the fourth quadrant, because of this having to be negative. Okay, so that's very important, guys. Now we have 8, 17, and negative 15. Can we now find tan theta? Tan is what? Opposite over adjacent. Here we have our opposite side. There we have our adjacent side. All right, so therefore, tan theta is equal to opposite, which is negative 15, over adjacent, which is 8. Which is, I suppose we could have done that right from the start, which is just, let's write it in its simplest form with that minus in front of the whole fraction, not just in the numerator, negative 15 over 8. Now guys, if we go back to the class diagram, which trig ratio is the only one that should be positive in the fourth quadrant? So tan is supposed to be negative. All right, because the opposite side will always be negative there. That's also a way of checking. If you're now getting a positive answer for tan in the fourth quadrant, but you know it should be negative, that should tell you that you've done something wrong. Okay, so guys, let's just write some steps down quickly of what we did here, because it is a bit of a tricky thing. So I'm just going to make a little star here. Use the given information to decide which quadrant the triangle is in. Remember, that was our first thing that we had to figure out. And we also use that information, specifically the fact that cos was 8 over 17, to fill in 2 of the 3 sides. So, and to fill in 2 of the sides. Then use Pythag to find the third side. Okay, any questions on that first one, on A? Let me find it back. Okay, I want you to do B on your own quickly. You're going to find sine squared theta plus cos squared theta. So guys, are you going to draw the triangle again if it's already in A? No. All right, you now can just use the triangle to read those values off and then actually calculate what that will be. In this case, also, we don't really mind if you actually use the calculator to square the numbers, all right, because we have 15 and 17 and 8 is fine. 8 squared, obviously, we all know is 64. 15 squared is 225, all right, but the 17 might be a bit difficult. So again, the not using a calculator thing is more for just letting you know that you have to draw a sketch. Okay, you can't find the size of that angle. So do that one quickly. You're going to find sine and cos. You're going to square them and add them together and then simplify. All right, do that quickly on your own using the triangle that you've drawn in A. We have an answer. Okay, let's take a look. All right, there we go. Sorry, that is quite small, but I just used my triangle to get that sine was negative 15 over 17. But they're saying sine squared. All right, so you're going to square that value. Plus cos squared. Now, guys, they actually gave us cos theta, so you didn't have to use the triangle for that. Okay, but you could have. You would have gotten the same answer. 8 over 17, but because they said cos squared, we're going to square that. Now, guys, just because it does say without the use of a calculator, and it will probably say show all working, just put in some in-between steps so that it kind of looks like you didn't use a calculator, right? Please don't just go straight from this to 1, all right? I don't know if they will take off marks, but they might, yes? So it will be 1, 2, 3, I suppose, but they might, if the instruction is saying showing all working, they could take off a mark if it's not there. Okay, so rather play it safe. Let's put all our steps there. Okay, all fine with that. We're going to do one more quickly, but I actually want you guys to draw your own triangle for this one. So I am busy just writing it down. I will help you kind of get started though. And then it will be homework for Wednesday. Okay, there we go. Just write that down quickly. Okay, grade 11s, I'm just going to give you some hints on how to get started. This is going to be your homework for Wednesday, all right? They haven't told us what sine theta is equal to, like they did in the previous one. They said cos theta equals 8 over 17. They've given us this, but can't we solve for sine theta there? Move the plus 3 over, it's going to become minus 3. Then you're going to divide by 7. So you're going to have where sine is negative, all right? Where is sine negative in 3 and 4? We just did that one, right? Didn't we? Yes. Now theta must be between 90 and 270. You need to figure out which quadrants that will also be, all right? Between 90 and 270, then you're going to draw your triangle. All right, there are still 2 minutes left. I don't know why they keep on mulling about outside. So just chill, please.